Good afternoon, everyone. My name is Nick Brauwere. I'm one of the vets at Redwings Horse Sanctuary here in the UK, and I want to welcome you to our webinar on Strangles and West Nile virus, which will be presented to us by Dr. Richard Newton from the Equine Infectious Disease Surveillance Group based in Cambridge. Um, Dr. Richard Newton is an expert in veterinary epidemiology, and the work he does helps us stay alive to the threats of infectious disease to horses here in the UK by collecting data not only from UK labs, but also monitoring threats from all over the world that could potentially be a challenge for us here in the UK. So we are going to hopefully have plenty of time for questions at the end of the presentation by Richard. The decision to choose this title, I think, Richard, came from various discussions we've had in the last year over the emerging threats and how we often talk about these as vets, but they always seem to be distant. And we know flu and we know strangles. And obviously, a lot of our work around strangles and this week of SOAR is all about helping people prepare to avoid contracting strangles. And if they are unlucky enough to have that disease on their yard, to then know how to get themselves out of that infectious state as quickly as possible. But strangles isn't the only equine infectious disease, and we perhaps, as I said earlier, are familiar with equine flu as well. And it is helpful to think of those exotic diseases that maybe aren't as far away as we used to think they are, and see how our general awareness of strangles and the threats it poses can help us maybe be better prepared for diseases that until now have seemed like a distant threat. So without more waffling from me, I'll hand over to Richard, and thank you very much.
Great. Thank you very much, Nick, for that introduction. Yes, as you've said, I think the organisers of SOAR thought that it might be interesting to do a compare and contrast with an emerging disease that we've not really had to think about too much in the UK, but we are certainly thinking about it. And as the banner at the bottom there shows, my group is supported by the horse racing and breeding industry, and they are alive to the threats that infectious diseases pose for that sport, but also for all equines. So hopefully this will be an interesting journey through comparing our old adversary strangles, as you see there, to this emerging threat, West Nile virus. So in thinking about what we're going to compare today, I'm going to look at the two pathogens. We're going to think about the routes of transmission and the clinical signs that are associated with those pathogens. We're going to consider how we diagnose the diseases. We will think about the global distribution and the UK status. And then finally, just a few slides looking at biosecurity and hygiene around the infections, and also considering vaccination as well, which is critical for the control of many of the diseases that we think about. So what are the causes of strangles and West Nile fever? I've called it West Nile fever here, although that is derived largely from the disease that was first noticed in humans. So the first important thing to consider is that these two diseases are caused by different organisms. Strangles is a bacteria of the Streptococcus genus, so Streptococcus equi, whereas West Nile fever fundamentally is different. It's a viral disease. The Flavivirus genus is the causative agent there. When we're thinking about these two different types of organisms, bacteria have their own metabolism, and that allows them to live freely outside of the host. They don't need to be inside a horse, although Strep equi is very well adapted to live within the host. Whereas viruses fundamentally are not free living, as they need host cells in order to replicate, and that's what they're really geared up to do. In terms of when they were first characterized, we go back to the early days of bacteriology in the 1890s when Streptococcus equi would have first been identified. And we have to wait nearly 50 years later when we're getting into the dawning age of virology, 1937, when the West Nile virus was identified in a woman with fever in the West Nile region of Uganda in Africa. Fundamentally, they're different. They're based on different genetic makeup. So DNA, the double helix, makes up strangles, whereas we have a rather simpler single helix RNA, which makes up the genome. So this is the thing that dictates how these organisms metabolize, etc. Larger genome, about 200 times larger in the bacteria compared to the virus. And that genome is made up of over 2 million pairs of these nucleic acid building blocks, and that codes for about 2,000 genes. Compare that to ourselves, we're about 20,000 genes, 2,000 genes in the bacteria, whereas only about 10 genes, the viral proteins, that's all they code for is their own makeup, no adaptation beyond that. So these images here, so Streptococcus equi, based on the Greek for coccus, which is a sort of berry-like structure, and they're strung out into chains and hence strips of coccus. The image that you see here on the right, West Nile virus, sort of captures the basic makeup of the viral particle, and a very high level of electron microscopy required there. In comparing the size of these, so on the left there you have the sort of basic coccus, and the virus, you have about 20 viruses across the width of that organism. So about 8,000 viruses would take up the same volume as a single coccus. And you can see how the scale of these things are in fact very, very different. So we then got to consider, how does this organism Streptococcus equi, how does it cause strangles? And so I'm going to credit my good friend and colleague, Romain Peot, for these images here that he published in the EVJ in 2017. I think they represent this very nicely. So this involves the horse acquiring this bacteria either through the respiratory route, or probably more commonly, it's taken in through the oral route. These organisms will track to the back of the throat, and they will sit there, and within the different tonsils that are sitting there at the back of the throat, they will invade very quickly. And that's probably within a matter of only a few hours. They will translocate to the lymph nodes at the back of the throat. And there are several of these strings, the ones under the jaw, the ones adjacent to the guttural pouch, and then some higher up as well. And it's once they start to get into these sites that they start to cause the damage, and they start to then coalesce into initially microabscesses, and then they'll become abscesses. And it's when these structures then rupture that we start to see the classical clinical signs. So that submandibular lymph node there, number 4, as you see there, that will break out. So you get the classic signs there. The retropharyngeal lymph nodes adjacent to the guttural pouch, when they rupture, often they will lead to quite a profuse and acute onset nasal discharge. Any that aren't cleared will then form into chondrule within the guttural pouch. But the important fact is that all of these exudates, all of these discharges from these various sites have a high amount of the Streptococcus equibacteria. And if these are acquired by another horse in close contact or indirectly, then that's how this disease can then spread through. So in summary, the clinical signs of strangles, they will cause fever, they will cause animals to have high temperature, they'll go off their food, and they'll really be quite sick and depressed whilst they're in that phase. You've seen how the lymph node abscesses, those under the jaw, the submandibular, the parotids up the side of the face, as you see in that lower right-hand image there, and also the retropharyngeals, which you can't see images of here, but they're inside the horse and will rupture into the guttural pouches. We may well see a phase of this disease where we see this marked mucopurulent nasal discharge. We may also see animals coughing, usually a softer cough, not the harsh dry cough that we see with flu. You may get conjunctivitis, so the infection tracking into the mucous membranes of the eye, and you may also see ocular discharge, from which you can also recover this organism. There are some rather nasty complications of strangles. So what's been termed bastard strangles. So this is where the organism will move quite a distance from those lymph nodes of the head, and that can be really in any site of the body, depending how far it tracks. This may be accompanied by what we call non-specific signs. We don't really, they're not attributable necessarily automatically to strangles and need to be investigated. And if this is, really complicated, then this can be a cause of death, mortality with this disease. There's also another complication called purpura hemorrhagica. This is an immune-mediated disease where the horse's immune system really reacts against the bacteria. And then we see these rather distressing images that you see in the right here. So we get mucosal bleeding, swelling, and discharge from these sites. So let's contrast that with how does West Nile virus transmit to horses? Well, the first thing to understand here is that the life cycle of this virus actually circulates between birds and mosquitoes. So mosquitoes are then acting as a vector. They are carrying the virus. When they bite on infected birds, they'll then go feed on non-infected birds and they will transmit the virus in that way. So that's what maintains the cycle. The bird is what we call an amplifying host. The virus will amplify and therefore be able to be spread on. In most birds, and with most West Nile viruses, this doesn't cause a problem, although occasionally we do see birds being killed by this, and that can be a sort of cardinal sign that this infection has moved into different parts of the world. Where the horse comes in and the human, and we need to consider that as well. Obviously, horses and humans spend a lot of time together. These are what we call spillover or incidental dead-end hosts. And it's when those mosquitoes are able to go and bite horses and humans, and not all mosquito species will do that, that they will then introduce this infection. And there is a risk that both ourselves and our horses will become infected. So when we look at this in a little bit more detail, and don't be too worried about the detail that's in here, but we get this sort of local introduction of the virus. The mosquito saliva will allow that to resist the immune response initially. That virus can then spread into the lymphatics and the bloodstream, so we get a small level of viremia. And the important thing there is that this virus can then disseminate around the body of the infected individual. And at some point, if circumstances allow, we get this neuroinvasion. So the virus will find its way into the CNS, maybe the brain, it may well be further distal down the spinal cord. But there are a number of ways that this virus can then be introduced, although not all horses are going to present with this infection. In fact, most of them won't present with neurological signs. And then once this virus is in there, the brain is largely represented here, but as I've said, it's down the CNS, then that can lead to inflammation, cell death, and then we get the relevant signs according to which parts of the CNS are infected. And that may well be multiple, leading to quite a broad range of clinical signs. So this one slide here does represent really the spectrum of signs that we may well see. And you'll see at one end, we've got coma and death, and the other side, we've got no signs. So actually, the vast majority of horses here will not actually show clinical signs when they are infected. The next sign is fever, and this was a name that was coined with humans, so it's seen more frequently in humans than it is with horses. So a large proportion of horses, even though they're infected and have other signs, may not go through this phase of fever. And then really we've got everything from sort of general depression. They may well be sensitive to the touch. There may well be muscle weakness and twitching, impairment to the vision, difficulty swallowing, and all these different signs, all the way through to narcoleptic episodes, sudden fainting. There may well be limb incoordination, weakness, and then complete loss of movement, animals entirely down, paralyzed by this infection. So a broad range of signs, and some of these can be very disturbing. And as with other neurological diseases in horses, if they remain down and don't recover, then often they are required to be euthanized on humane grounds. So, can be a very distressing infection and disease. So then we're turning our attention now to how we diagnose these infections. And what I've represented here is really the sort of classical pattern that we would see with many infections, and then the immune response that follows. So this is the way that the horse will try and deal with this based on its innate immunity and its responsive immunity to deal with that infection. So often at the time of infection, the antibody levels are low, the immune system is not set up to go. The pathogen will be introduced. It will then be able to reproduce and start to do its damage. But over time, the immune system will kick in and will start to clear the pathogen, and we see that decaying. And you can see that depending where we look, we might be able to make diagnoses at different times within the time course of the infection. So diagnostic assays really fall into these two categories. We've got the direct identification of the pathogen. Is it present with the horse? Can we detect it? Or are we reliant on indirect identification that the pathogen has been there, the horse has been exposed, and therefore we're able to detect it? And perhaps if we think that in a sort of criminology type of way, where we're identifying the pathogen, we're actually apprehending the criminal. Is there on site. We've got him apprehended. Whereas with the indirect identification, we have to question the witnesses, such as the immune system. Perhaps we can retrieve the fingerprints, the evidence that this individual, this criminal, this pathogen was actually there. So in thinking about direct identification, in some circumstances, particularly strangles, traditionally, there was culture of whole live organism. We can demonstrate that we've recovered the live growing organism from the site of infection, and therefore that confirms the diagnosis. Although increasingly over the last number of decades, all diagnostics have turned their attention to much more sensitive and rapid methods, where actually you're amplifying up only part of the genome of these organisms, such as the DNA or RNA, and these are using PCR methods that can be adapted to both viruses and bacteria. And some of these are now available on desktops within veterinary practices, so-called point-of-care assays. So the indirect identification, the detection of antibodies, this often relies on the ability of those antibodies to physically interact with biological proteins, agents, etc., which can be done in the laboratory, and then we're able to demonstrate the presence and often quantify the amount of antibody that's present. And the most commonly used method for that is something called ELISA. It's an enzyme-linked immunosorbent assay, and that's very commonly used. And in the bottom right-hand corner there, you can see a plate with color changes within that, and that's demonstrating the presence of color changes, demonstrating the presence of antibody. And both of these methods are in fact used for both of these diseases. So thinking about strangles outbreak management, we do have to deal with this very commonly. And this is a matter really of using a traffic light system, separating this population as appropriate into red, amber and green groups. So the clinical horses with clinical signs that we know to be either highly suspicious of strangles or have been confirmed, they would be within the red group. We know that they pose an infectious risk. There may well be in contacts of these animals who may well have been exposed to the organism and therefore need to be monitored carefully because they may subsequently become sources of infection. And not in all outbreaks, but there may be groups on premises where there has been no contact, either direct or indirect. This is the green group. We can't completely forget about them. They need to be investigated, but hopefully they are a lower risk. And in thinking about that risk as we move around and you're managing these, it's always sensible to think about the way that we move from the low risk through the medium risk to the high risk, and not in the other direction, because that obviously can transfer infection and make matters worse. We need to think about the equipment that's dedicated to these groups, that we're not moving that around. There can obviously be indirect as well as direct transmission through these things, such as buckets, feed troughs, etc. And that needs to be thought about as well. Monitoring these infections, monitoring these animals for signs of infection, often temperature taking, really important message still around sore. And where those detect disease, then we need to be prepared to move these animals in order to reduce the risk in those existing groups. So what has this got to do with diagnostics? Well, in strangles outbreaks, we do adopt or we do advocate the use of testing to help with control of outbreaks. And so we will use this ELISA, the blood test, to establish whether or not there has been exposure to the organism. It's very useful for that. Whereas detection of the infection itself will often be used in order to demonstrate that the infection has in fact been cleared and that these animals are safe to move. So we will tend to use the blood test in the amber and the green groups, not the red groups. They've already been confirmed. And this will inform the extent of the existing exposure, and it may well identify animals that we do need to do further testing using bacteriological screening. We will often advocate that the red group animals undergo guttural pouch endoscopy in order to detect those infections that wouldn't otherwise be detectable after disease. And also any animals that have got evidence of exposure in the other groups, we'll probably look at those as well. And generally speaking, these will be subjected to PCR, which is more sensitive than culture. So let's contrast that a little bit with West Nile virus diagnosis in horses. As we said earlier on, there is generally insufficient viremia within these animals to infect mosquitoes and therefore pass the infection on. And that also means that there is generally going to be insufficient virus detectable and for a very short period, such that qPCR, although it's sensitive, is generally not used as a diagnostic, certainly not in live horses. So we are reliant on detecting this really quite marked increase in antibody. It's a class of antibody, a class of immunoglobulins called IgM, and those will rise very rapidly after infection. And we are looking diagnostically within West Nile virus to detect those early on in the course of the infection. There is another class of antibodies called immunoglobulin G. Those will generally appear later. They may be diagnostic, but they can also be induced by a vaccine. So again, there can be complications there in terms of interpretation. So turning our attention to where in the world does strangles and West Nile occur? Well, this map here is quite old. It was taken from the CDC in 2006, but it really represents where West Nile and its different forms have been seen around that time. Maybe a bit of South America is a little bit more yellow now, but I think this represents it well. And you can see that there in Europe, there is presence of virus as well, obviously still in Africa and across Asia as well. In considering strangles, I've taken a slightly different approach here, and it's probably easier to think about where strangles isn't present because it is so widespread across the world, and we believe it is present on almost all continents. The notable exception actually is Iceland, and the important message here is that they have not imported a horse in more than 1,000 years. They came in with the Vikings and they've only been exporting them ever since. So they have not brought in these problems. And indeed, there isn't evidence in Iceland that they've ever had equine flu, equine herpes virus 1, West Nile virus, obviously, and also strangles. Although an interesting note is that back in 2010, very closely related organism of which strangles is a subtype, Streptococcus zooepidemicus, did cause a major respiratory disease outbreak on Iceland, and they were able to track this back to sort of one source, a training centre down in the south of Iceland, from where they were able to track a particular strain of this infection, and it really went all over Iceland very, very quickly. So this, if nothing else, really highlights the risk that Icelandic horses in Iceland are should strangles get in there, because it would almost certainly behave in a very similar way. So thinking about whether we have West Nile in the strangles and West Nile in the UK, well, we certainly have strangles, as you're probably aware. It is endemic within the UK. The image that you see here is taken from the Surveillance of Equine Strangles website that Dr. Abby McGlenn in my group operates. And here you see a representation for the year period between the 22nd of April 25 and then 21st of April 26, over 500 diagnoses from 157 submitting practices and across a wide area of the UK, including Scotland, Northern Ireland, Wales, and England, as you see there. So really is a prevalent problem within the UK. In contrast to that, West Nile virus is considered exotic to the UK. We haven't got this disease or this infection circulating as far as we know, although it has been reported twice in horses in this country, one in 2013 and one in 2022, and I'll touch on those very shortly. However, what's important here is that both of those had been recently imported from Europe, And it's believed that West Nile virus exposure was not in the UK, but it was whilst they were away in Europe, residing or indeed travelling through. Although a slightly concerning recent development was that RNA was detected in UK mosquitoes in 2025, and I'll touch on that very briefly. So this first case was picked up in 2013, and as their summary describes, so they detected the antibody in a horse in the UK that developed neurological signs. It had recently been imported from Europe. In fact, it traveled from Cyprus across Europe over land, and it's believed that it picked up the infection at some point during there. And this was really a warning sign for horses traveling through Europe at critical times of the year. The more recent case was a fatal case that had returned to the UK from Spain. This was a young animal that had been out competing in southern Spain, and it's believed to have picked up the infection there. And they include this very nice timeline so that it shows how the horse was abroad for several weeks in October, started to return, came via France, developed signs while it was on its way, was admitted to the Royal Veterinary College Hospital, very switched on clinician, noticed this, looked at the travel history, got a confirmation that this was, and unfortunately the animal subsequently deteriorated and they were able to isolate or to detect the actual presence of virus in detailed post-mortem investigation of this case. So absolutely confirmed case, almost certainly acquired whilst abroad. So these were the headlines in the BBC, on the BBC website back in May of 2025. Quite a worrying headline that West Nile virus had been detected in mosquitoes for the first time. Obviously, a lot of concern within the industry and human health people at that time. When you look more closely at this story, this was actually on the back of a research project that had been undertaken. So some mosquitoes had been collected in July 2023, and they were subsequently tested in 2025, and they found evidence based on the RNA that West Nile virus had been present in a small number of these mosquitoes. So worrying that it was found, but there hasn't been evidence that it's been found since, but certainly highlights the importance that, you know, we could be in an age where we do start to detect this infection. So how did Strep equi achieve this world domination, all places it seems apart from Iceland? Well, the secret of its success is that it's its ability to be carried by outwardly healthy horses and then transmit. So this representation here is a Strep equi infection met by a healthy susceptible horse, will then incubate that infection before developing signs. And there's also a period called the latent period, and that's where the animal will not be infectious immediately after it's become infected, but will then become infectious before signs appear. So we have this sort of post-latent period where animals that are incubating infection are still infectious and can transmit. Probably more important, and I'll present a little bit of work that highlights this, we have recently convalescing animals. Their signs have all but disappeared, but they're still infectious, and they can be like this for quite a number of weeks. And we think it's these animals that are probably the most important in modern day transmission of strangles. Work that Nick and I did a long time ago also confirmed that some of these animals will hold on to this infection, particularly in their guttural pouches, and will be potentially susceptible as long-term subclinical carriers after strangles. So I just wanted to really present some fairly recent work that Dr. Abby McGlennon in my group did as part of her PhD, where she collected organisms from outbreaks of strangles over a number of years, and the period really was 2016 through to 2022. You'll see the glaring omission in 2020. There was a small disease called COVID that got in the way. But actually, what's neat here is it doesn't change the story at all, even though we're missing an entire year. And the story here is that the type A strain became much more prevalent, much more common, was detected far more commonly during this period, and it seemed to replace this type B strain, which became much less commonly identified. And that is a very short time period for this to happen, and can only be explained by long-term carriers not contributing to the persistence of strangles in this country. So it really highlights how recently convalescing animals are believed to be contributing to the transmission of strep equine. So Abby did found some local transmission, and that was particularly, for example, in Dartmoor, area that Nick was heavily involved in. But also she saw some really widespread direct transmission going on across wide areas of the UK. And by looking at the genomes of these organisms, seeing how related they were, putting in certain assumptions, she could track these isolates around the country with direct links. And you can see here we've got outbreaks in England, Wales, Scotland, Northern Ireland again, some direct, some not direct. And this was all happening within a matter of a few months. So we were getting rapid transmission between these areas and could only have been explained with recently convalescing animals having been moved after strangles outbreaks. So let's consider whether West Nile virus is changing its distribution over time. This is an article that we put out onto one of our quarterly reports a number of months ago now, last year. And this highlights this map here. So this was work done by Simon King, a Cambridge veterinary student, and he looked at data that the European Centre for Disease Control were putting out, mapping cases of equine West Nile virus. And so you've got three coloured areas here. The green is for the 4-year period 2017 to 2020. So these are the areas where West Nile was only diagnosed in that period. And you can see that that's relatively small amount of the map with West Nile like that. The red areas, that's where West Nile was confirmed in both 4-year periods, 2017 to 20 and subsequently 21 through to 24. And you can see that these are the sort of Mediterranean coast areas, the areas that we'd consider to be endemic for West Nile. And then we have the blue areas. So these were the areas where West Nile had not been confirmed prior to 21, but then did emerge. And you can see that we are starting to see the movement and emergence of West Nile virus, particularly further north up that Atlantic coast in France, further north into Germany, and also filling in the gaps in Spain. If we look more recently, this was the picture in that we've seen in 2025 since the middle of the year. And we are seeing cases confirmed in the Netherlands, in the middle of France, where it hasn't been seen before. And if we overlay that map, you can see that just within that 1 year, we're getting parts of Europe confirmed with West Nile that we haven't seen it in the 8 or so years previously. So clearly a changing pattern of disease that we're seeing with West Nile virus. And we are putting this down to climate change. It does seem to be changing the disease risks, probably by changing the environmental conditions and the ability to sort of sustain these insect vectors. And this has implications for other diseases as well, such as African horse sickness. So should we see that? That's a midge-borne disease. So that probably is why we're seeing this changing distribution of West Nile. So just drawing to a close now, what about biosecurity measures that are relevant to strep equine? Well, we need to remind ourselves of these two images. So these animals with these discharges, they are key in terms of biosecurity measures. Obviously, restricting horse movements on and off affected premises is important. We don't want these animals carrying these infections off. Using the red, amber, green traffic light system to separate out groups, limiting both direct and indirect transmission, as we highlighted, avoiding direct horse contact, but also thinking about indirect transmission, use of dedicated staff, clothing, equipment, and obviously, wherever possible, using thorough cleaning and disinfection. In terms of West Nile virus, this is really about mitigating mosquito biting where we know that the virus is present. So this schematic here I've taken off the internet. It's an American publication, but it really highlights the importance of thinking about mosquito breeding sites, what times of the day that horses get turned out, what protection is offered through sheets, either of housing or horses themselves, and also use of repellents. And these are things that we've not really had to think about in the UK before now, but the chances are that in time we will have to start considering these. So are vaccines available for these two diseases? Well, they are, and we've got a relatively new vaccine called Strangvac, which is available in Europe. This is a fairly simple vaccine based on protein subunits. And the importance here is that there's no live organism, there's no DNA, and this animal, therefore, this vaccine therefore has DIVA capability. We can therefore differentiate infected from vaccinated animals quite readily, and that is a really important step forward when it comes to using this vaccine in control. It's given into the muscle like most horse vaccines. Obviously, it has preventive use, but we think it can now be used in the face of outbreaks, and that's a really important step forward. West Nile virus, there are a number of products available in Europe. These were all developed after West Nile virus spread into the USA after 1999. There are various technologies adopted, and even some of these are simple inactivated whole virus vaccines, highly effective and do a really good job in protecting animals. However, they're not DIVA, certainly not the simpler ones. They are given intramuscularly, and they clearly have preventive use. That's how they should be being used. In fact, we have been advising horse owners and vets advising their clients that, horses traveling to endemic areas, including Europe, and you've seen how that's changing, do need to consider using these products before they take those animals into those endemic areas that I've illustrated. So in summing up, strangles obviously occurs when horses are exposed to the organism Strep equi, and the disease control definitely relies on preventing the transfer of bacteria. We need to think about how outwardly healthy infectious horses transmit this disease, and that subclinical infections facilitate efficient transmission. In contrast, West Nile virus is transmitted by infected mosquitoes. The horses are dead-end hosts, so they don't themselves transmit West Nile. But the global distribution is changing, and probably is global warming that is sitting behind that. So strangles is endemic here in the UK. West Nile is exotic to the UK. And we do need to think about how we use diagnoses and use of control, etc. And then finally, we do have vaccines, and they really are an important method or consideration in thinking about disease control. So I will end at that point, and hopefully we can have some good discussion. So over to you, Nick.
Thank you very much, Richard. We do have a couple of questions already. And the first one is from Mertha Vessel. Hopefully, I pronounced that correctly. It says, how specific is antibody testing for West Nile virus? If you look at cross immunity with comparable arboviruses like USUV, etc., can we say with 100% certainty a horse is positive for West Nile virus?
Yeah, it's a good point. There will be what we call cross reaction. And therefore, there is a need often for alternative methods that are able to differentiate between the actual causal agent. So yes, there will be this sort of idea that cross-reacting antibody could occur due to a different virus. I think that's may be important, but I think often you want to know, is it a flavivirus that's caused the problem? There was an interesting case in the UK actually that occurred in Dartmoor, and we wrote that up in a recent edition of the Quarterly Disease Surveillance Report, and that showed actually that the initial test that was applied, the IgM, was negative for West Nile, but it did turn out to be something called Laupingil, which is a tick-borne flavivirus that we have in the UK, and so they were able to decipher that in time. So yeah, it is important to differentiate, but often you just want to know that you've got a flavivirus that's caused the problem, then you home in to find out which one it was. Usutu virus we have in the UK, circulating between garden birds in certain parts of the country, does seem to be extending its range, potentially can cause problems in horses, although I think it is quite rare.
Thank you. Then Sarah Versden was asking how quickly the vaccination takes effect once administered.
As with all vaccines, it's not instant, and it depends to what extent the animal has been primed. So classically, when you are starting a vaccination program, you are usually giving two doses of the vaccine, one to prime and then to, boost that boost that response. Classically, it is a matter of weeks between those, and you're probably looking at 4 weeks between primary course doses, and then only seeing the peak response 2 weeks after that. So it can be a relatively slow process. Probably as you're aware, Nick, there is questions about Strangvac at the moment. Given the close relationship between Strep equi and Strep zoo epidemicus, we actually think that horses are probably being primed by natural Strep zoo epidemicus infection. So we're probably seeing a better response to first dose of Strangvac than we might have expected, although people will need to follow obviously what's on the data sheet, the SPC, to go through that. But the response after one dose, I think, has been very, very encouraging. So that looks good for use of Strangvac.
Yes, and I think that's sort of an area that we're curious about because it was not why Strangvac was developed. But it seems to have been a very happy coincidence that some horses might have that priming immunity of some sort, which means it has dug a few people out of a hole when the outbreak's already started and they've been able to protect other horses. But it's not how vaccines usually work, is it?
No, but you and I know the developers of that vaccine very well, and before they got to that point, they were aware um, that Strep equi is sort of the black sheep of the Strep zoo family. It's those organisms are actually misnamed. It shouldn't be Streptococcus equi subspecies equi. It should be Streptococcus epidemicus subspecies equi, and they're very closely related. So when they were choosing what went into into those vaccines, it wasn't a surprise that there was this sharing of those proteins. So I think they've been very pleasantly surprised that we are getting that sort of evidence of some sort of cross protection as well as cross reaction, and it does bode well that vaccine may have some benefit for other types of infections caused by Strep zoo epidemicus, which, you know, people may just think of it as a commensal, as a sort of a bit of an annoyance, but it can be very nasty as well, and is potentially zoonotic as well. So, hopefully, it bodes well for the use of that vaccine.
While we're on Strangles, I've got a couple more questions there, and then we'll come back to West Nile virus. So Alejandro asked, is it recommended to use Strangvac to face an outbreak in the three groups, red, amber, green, or only in the red ones, or all the animals in the same facility farm? I'm guessing there we had a meeting not that long ago where that was exactly the subject of discussion, and I think it may well be that the advice will vary very much depending on the yard that you happen to be on and the layout of the yard and how the
Mm.
infection got in and so on. It's not as straightforward, but I think what are your thoughts on that?
Yeah, I mean that's a very opportune question, and I mean I've left these slides open, so what I'll do is I'll quickly scan through if I can. Let me just see if I can resurrect that. So yeah, so just a little plug here. This was a paper that came out in 2024 following a meeting of experts in Sweden in the December before this. And we were really looking charged at discussing strangles vaccination and really what was our sort of thoughts around it. This has then recently been followed up with another meeting only uh, last month up in Edinburgh, and that's the group there. And again, we've been looking at the evidence further, and I will skip over that bit. But yeah, there is a growing sort of thought that we can use Strangvac alongside the traffic light system. And if you think about the green group, they're the healthy, unexposed. There's kind of no reason to not get on and vaccinate those animals quickly and start to hopefully see the benefit of that. So we are recommending that that be done. But we're also now thinking that can be applied to the amber group. They may well be exposed. There was some discussion, as you know, Nick, around the potential for seeing some animals with reactions with mild temperatures going up for a few days after they're vaccinated and how that might mimic the early signs of strangles. But I think the general consensus was that actually you can either get on and start that use in the amber group immediately, or you could delay that for a couple of weeks to just make sure that any animals incubating infection have kind of sorted through that. And then you get on and vaccinate those animals as well. And you may go a little bit more frequently in terms of how often you boost them, depending on the risk. And there were also thoughts about the red group as well. There was a little bit of discussion about how soon after recovery that could be done. Some people had the view that it could be done sooner as long as they were well. Others were more willing to leave it a little bit longer. Certainly, biologically, there's no need to go in with vaccine. They should have mounted a natural immune response. So, yeah, there are ways now, although they're not in the data sheet, but the people around this are starting to think about using vaccine in the face of an outbreak and considering it within all three of those in all three of those groups. Sorry, rather long-winded answer to the question.
I think it just illustrates how complicated the disease is, and also I think there's two important points, aren't there? One is that with Strangvac, it's relatively safe to vaccinate a horse who might your timing might just coincide with the horse just developing clinical signs, and that what we really don't want to do is vaccinate a sick horse that's got a fever with the vaccine, because that may cause problems. And I think they have seen issues with some of the other strangles vaccines where that unhappy coincidence of injecting at the same time as the infection is just taking hold in that animal can have fairly catastrophic consequences. So it's not something that you just want to do willy-nilly when you talk about the amber group and the red group. So it has to go hand in hand with careful monitoring and checking, and your vets being comfortable that your biosecurity measures and records and all that are up to scratch.
Yeah, it's absolutely critical. I mean, we mentioned that condition purpura hemorrhagica, and certainly there is a thought that some of those vaccines out there, based on what they have in them, could exacerbate that if you're vaccinating in the face of an outbreak. There's no evidence that this is an issue with Strangvac at all. The components have not been associated with that at all. So, not ideal, as you've said, and you wouldn't want to be vaccinating sick horses. They would need to recover and demonstrate that they were on the mend. Yeah, so yeah, working closely with the vet. And I think it's really important for vets to convey, the ups and downs of this approach, and it's not absolutely guaranteed. And I think that communication around, what may happen is really important. But I think the impression I've had, particularly from colleagues in Sweden, is that actually we heard some recounts from France as well, didn't we? Where actually the benefits have been, really good. I think their experience has been very positive.
Thank you. We're now getting a good flurry of questions. Before we come back to the West Nile virus, Holly Vince, should owners be considering the strangles vaccine as part of their routine vaccination program alongside flu and tetanus, or is it more appropriate to take a risk-based approach? I think my view is both of those sort of hold true. I would say if you look at the list from that last consensus paper that went into the equine veterinary education, and pretty much by the end of it, it listed every type of horse that's kept where strangles is a risk. So yeah, it probably would be sensible to add it to your routine. And I think a lot of yards in the UK where they've had outbreaks have then seen vaccination with Strangvac as a way of avoiding it happening again, because some of these yards actually had very good biosecurity processes that just weren't quite perfect for that one time that it slipped through. But I don't know if you've got further thoughts, Richard.
No, I largely agree with you. The interesting population is the racehorse population, and that there is a zero tolerance to strangles in that population, and therefore they, they do have to go heavy on the control measures, and we haven't gone down the vaccination route just yet. But I think it does add an extra layer, and I think it does make things a bit safer for the next time. And I think our experience will probably show that it will become more routine. I didn't show the
Okay.
slide there, but I think it will make moving horses into populations much easier. But that is based on the fact that you're pulling animals into an already vaccinated population, and they have to join that group and therefore start and ideally complete vaccination before they join. And then it doesn't mean you do away with quarantine. You don't do away with, investigating where you have clinical signs developing. But because this is a DEVA vaccine, you can get on and use those diagnostics with confidence. The waters are not being muddied by the vaccine, and you can then get on top of it quickly, and the vaccine will have helped limit the spread and the severity of any disease that's seen.
And then, because I think being Strangles Awareness Week, we're getting good questions around strangles. So that I don't forget them, just one from Gail Eggington. What is the DEFRA policy plan on increased cases of West Nile virus into the UK or preventing it arriving in the UK? That's certainly not one I'm confident about, Richard.
Um, yeah, I mean, obviously, this is an important One Health consideration because there is human health as well. Um, to be fair, DEFRA and APHA have made. I mean, the slight issue for a while was vets weren't finding it easy to investigate these potential cases, and indeed to rule it out, even though the risk may have been thought to be very low. That has been made a lot easier now, and recently was made even simpler, so that previously vets who wanted to rule this out would need to speak to somebody from the APHA and organise the test and go through the test to exclude route there. Now they can submit those straight to APHA and have that ruled out. So hopefully it's a lot easier to do the surveillance. And certainly from the industry point of view, we want to know, are we getting that circulating West Nile virus in the UK? We're not there yet, but that may change. And the importance there is that if owners want to then protect their animals using vaccination, the industry needs to have that vaccine available, and be able to access it and use it at strategic times, as some of them are doing, not many at the moment. So the whole landscape about vaccine availability, number of doses available, etc., will have to change. And thankfully, I think the authorities have recognised the horse is not a risk. Therefore, you don't need to do anything draconian in terms of, you know, making sure that animals are put down and that sort of thing, which we do see in some dreadful disease incidents. So hopefully the whole thing can be fairly measured. But humans will have to think about this themselves. If we've got infected birds and mosquitoes out there in the environment, protecting themselves as well as their horses.
And I suppose that's a good plug for the value of surveillance and having access and keeping an eye on websites like EIDS, where you have your own information, but you also present from other services. So it's a sort of one-stop shop for keeping up to date. You can get the quarterly reports. So if you're traveling to Europe a lot or something like that, you could actually just make it your business to follow up with those. And of course, there's also Telltale, which is a service for professional horse people, where you register and they will then send you text alerts of influenza. And I think we're also seeing a few other things creep in as well, aren't we, that are helpfully being shared by text.
Yeah, so thanks for that plug. This is a service that we've has been provided by Boehringer Ingelheim. So a plug for them, their long-term support. So they essentially pay for this service. So where we have equine influenza, which is currently we're putting quite a number of reports out about that. We have neurological EHV. We have pregnancy loss with EHV as well. and also the exotic. So West Nile virus would fall under that. And indeed, we did use Telltale to inform, like you've said, vets and professional horse keepers that West Nile virus had been confirmed in the UK at that time in 2022. So we find that's a very useful service. Obviously, whichever part of the UK you're in, we do report at the county level. So hopefully it helps to heighten awareness and then for those vets and their clients to be responsive to that. So think about flu vaccinating if you know that flu is in the locality.
Thank you.
And there you see the pop up on Telltale. So
Yes,
thank you
I've
very
had
much
a
to
few
Hannah for popping
messages
that in.
this afternoon while we've been on. Um,
Yes.
Hannah Thurston asks, and I can answer this one, are you building a plan of action with commoners' councils for where West Nile virus could hit a feral population? I think I think we know that basically equine identification is critical to knowing where horses are and being able to protect. And I think a lot of the work by the whole horse industry is pushing for a robust system of equine identification with a live database that knows where horses are, so that we can actually help owners know when the risk is actually coming closer to their door, and also track it. The commons kept ponies are one of those areas where there's a real gap because they're not always identified while they live on the common, and not all of them are actually managed under a council. Many of them are managed under informal commoners associations, and that is one of the areas that Redwings and other charities have been working alongside people on the commons to try and have an informal way of making up for the gaps in the identification systems. But it is a risk that if the disease got into one of the commons areas, that it could potentially spread around that group before we actually know about it outside. And it is one of the arguments we keep making repeatedly to the governments that we do need to keep going with improving our equine ID. Um, so let me just scroll down. I think you've covered this, Sarah, asking, in your opinion, will availability of West Nile virus vaccine improve in the UK? She's asked for it,
Ye-
but
Yeah, the hope is yes. I mean, to be fair to the manufacturers, having large volumes of stock available on the it on the basis that it may or may not be needed is not good business policy. So they do hold relatively small volumes, and really it is waiting for demand to go up, which is not great, but we are waiting for that situation to change. And then we'll have to see. My slight fear is that we would be into a West Nile virus. It is a seasonal disease. We generally don't see much disease being reported, before the summertime comes, and then it can linger into the autumn. But switching the tap on for new, stock is not a quick thing. We are talking probably, 4, 5, maybe 6 months to bring stock online, and be available. There are possibilities for importing certain products from other countries, although again, that's not necessarily a quick fix. So yeah, we may have a period where there is a little bit of a shortage short term, and then we're into it. And I think even predicting, what would be required the following year with these vaccines and this disease is difficult. So we're just waiting to see what happens, really.
thank you, Richard. And then vaccines, but switching back to strangles, Alejandra's again asked about Strangvac and immune system reactions like purpura being related to subunit proteins. Are you happy to share there the sort of fairly lengthy discussions about the development of the vaccine and its efforts to avoid that, given that purpura has been seen with some other vaccines in the past?
Yeah, I'll try and keep it simple. Yeah, but basically, there's one particular protein which actually the experts such as Andrew Waller recognise. Their job is actually to divert the immune system towards it, and away from the other more critical areas. and that's believed to, what underlies reactions, severe reactions like purpura. So M protein is deliberately not in this product. Some previous products used elsewhere in the world are solely based on the M protein. So you can see how that they, that would be different. And I think today the safety record, certainly in terms of those severe reactions for Strangvac, has been really, really good. They haven't, the odd one, there were some question marks about that, but that they just have not seen those types of reactions with this product. And obviously it has been used quite a bit more, particularly in Scandinavia. So they have seen many, tens of thousands of doses administered. And they just haven't seen those issues. So
Yeah.
I think from that point of view, it's looking good.
And this slightly links to a comment I might make, because one of the questions was about why that wide gap of the 6 to 12 month booster for Strangvac. And I think it's fair to recognize that the development of Strangvac nearly didn't happen because a lot of companies didn't think it was worth taking on. And actually, when Intervacc decided to do so, they really couldn't do trials like 12-month immunity levels. So the information on the SPC, the data sheet that comes with the vaccine, is basically reflecting what happened in the initial studies that were done to get the vaccine licensed in Europe and in the UK. And given that we would all like to have a vaccine that works for 12 months, like with flu, the advice is based currently, the 6 to 12 months, on what we've seen with people who've used it frequently in Sweden and other parts of Europe. But to get licensed for use in America, I think they are looking at a much longer period, aren't they, Richard, to help answer those questions beyond the case reports that we've had so far about how long the immunity might last and when a good time is to boost with Strangvac.
And the other thing to say, again, coming back to my good friend and colleague Roman Peo, who is now working with Andrew at Intervacc, who developed this vaccine. They're doing some really neat work now, looking at those immune responses and modeling those and showing actually that it does look like the persistence of duration of immunity is longer lasting than was perhaps initially thought. And the hope is, and it is only a hope at this stage, is that that might well be reflected in the data sheet in time. But I think it's really encouraging that actually, the possibility of having longer duration of immunity, but also importantly, being able to use this vaccine when the risk goes up. If you've got a threat that strangles has come into a yard, it's well vaccinated, you can go in and see a good response quickly that will just boost that herd immunity, and we won't see the devastating effects that we might have seen in previous eras.
And then Louisa's been waiting very patiently for her question to be answered, which is, if I have a case of strangles in an American barn, should I move it onto the isolation barn? And would I put or move any horses with direct exposure into the isolation barn? So I think, Louisa, this really touches on the red, amber, green. And if you want more detail in terms of the generalities of that, the British Horse Society have just reviewed and re-released their STEPS guidance that has a bit more information on that. But do you have to comment on that, Richard, in terms of how, when you have that isolated case in a barn environment, you might go about it, especially with something like strangles that's not airborne?
Yeah, it's a really, really important consideration, and again, it's one of the best themes of SOAR. Separating animals is really important. You may have missed the boat, but at least give yourself a chance that you're doing that. Obviously, every local condition is slightly different. Not everywhere will lend itself to that type of really good separation. But with strangles, as you've said, compared to say flu, you don't need large distances. You just need to at least have several meters separation. That might be an empty box between two animals, as opposed to having another animal that can connect those two together. So there are clever ways that you could do that. Perhaps turning animals out, use of electric tape. We've used those in different disease scenarios as well. So, yeah, you have to be a little bit think outside the box, and adapt your local conditions as best you can, and think about those indirect transmission routes as well as the direct ones.
And I think also to say that it has been sort of shown that people can keep the disease from getting into a horse in the adjacent stable just with physical barriers as well. But it does really put a lot of pressure on the humans and the biosecurity measures that you have in place, like keeping equipment separate. So putting the horses in separate locations where they are proper red, amber, and green is the easiest in one sense, but you can often be quite effective in complicated situations like a yard where you don't have access to turnout to still protect it from spreading. So it's kind of very much a case by case. If you can hear snoring, I apologize. I think the Chihuahua is having a very good afternoon. Um, but just wanted to roll up again. Is there a chance of strangles being changed to a notifiable disease? Surely it would help with monitoring the disease research. Richard, this is an interesting discussion that seems to be every time the experts discuss it, there's a slightly different flavor about what actually happens in those countries where different types of notification have been put in, like Sweden, USA, Australia, for example.
Yeah, it rears its head every now and again. My personal view is I think it would drive things underground. I don't think it would particularly tackle things. You find that the labs stop actually confirming strep equi. They will confirm a beta hemolytic strep, but they won't speciate. The samples will stop going to the laboratories. Um, and there's absolutely no appetite in government DEFRA APHA for seeing this made notifiable. Um, yeah, I'm afraid it's probably gone too far for that. It is interesting that West Nile virus in horses is actually notifiable as an encephalitis, but strangles is not. I think it's incumbent on the industry to do much more than it is doing. It's seen as an industry problem, and I don't think making it notifiable will make any noticeable difference, if I'm being brutally honest.
Thank you. Just a quick shout out to Sam Lockhart, who has a big yard of 120 horses, and from next year on is going to require horses to be vaccinated with Strangvac in the same way as they do for flu, and that she will still quarantine new horses. Not all the liveries are liking the new rule in inverted commas, mainly due to cost, but ultimately Sam feels this is the best way forward. And I think that echoes a lot of what we've been saying, that actually in the long run, um, the cost of vaccination is nothing compared to the cost of an outbreak. And didn't Gitan, our colleague in Sweden, work out that the loss of earnings to a segment of the harness racing industry, the amount of money they lost would have covered the cost of vaccinating every horse in Sweden for strangles for something like 2 years. Um, so, the scales are huge. For those who've experienced it, I think the financial impact of an outbreak of any sort can be massive. So I think vaccination, where it's effective, is such a valuable tool.
Yeah,
Um,
totally agree.
and then Philip Dixon had a good question here. If West Nile virus vaccine does not have DIVA capability, would you advise using it for horses competing abroad? Or is there a likelihood of blood tests causing restriction on re-importation, etc.?
Uh, no, I don't believe there's a risk for that. I think people accept that the horse is not the risk when it comes to West Nile, and why would they be you know running blood tests for that? So no, it's not. I don't think it is you know a reasonable issue.
But I think it does illustrate the value of having made that extra effort in developing Strangvac to allow the blood test to still have a valuable role. And I think there are other vaccines and viral infections where you have that horrible situation that you can't tell the difference between a horse that's been vaccinated and one that's been naturally infected, and can have catastrophic uh, importance to the owner and the horse if that confusion arises.
Yeah, I mean the classic one we deal with, not all the time, but is there is equine viral arteritis. Stallions getting vaccinated, lapsing in vaccination, and then not being able to readily differentiate that, and further investigations requiring, looking at semen, etc., where this virus can reside. So yeah, I think it is shout out to the groups that developed Strangvac that was thought about. The blood test was thought about, obviously the PCR technology as well. So it's worked, yeah, works well, and I didn't go into it, but where there may be apparent breakdown of vaccination with Strangvac, not that we've seen that, but you can now go in and say, well, actually there is natural infection there, it's not attributable to the vaccine, etc. So yeah, it's a powerful tool.
Right. Well, we have, I think people who know us probably know we could talk till the end of the evening on Strangles, and probably need to recognize that it's 12 minutes past, so we might wrap it up. But as my colleagues have said earlier on, we will summarize the chat, and if there are any unanswered questions, we will happily put those into a Q&A, but you can always reach out to us directly as well. I would say for outbreaks and where you're concerned about managing things with epidemiology in mind, I would suggest going to Richard's group. But if you want to ask just about snotty horses and strangles itself, we're also happy to help here at Redwings. And I see Ahmed has asked a question for treatment of carrier state of strangles. And I think that's one that we could talk about for hours. So maybe you want to reach out to us, Ahmed, and we can share what we've done, quite a few of our resources on our strangles pages at Redwings, and in the SOAR literature generally talks about approaches for clearing carriers, which should be entirely possible in pretty much all cases. Well, thank you very much, Richard, for giving us your time and sharing your experience and knowledge. And hopefully that was as informative as everyone is expecting it to be. We had really good sign up, and thank you again. And we look forward to enjoying the rest of the week talking more about strangles and raising awareness. So thank you, everybody, and thank you very much, Richard.
Thank you, Nick.
Um, Redwings, can you answer? There's a question, where will the recorded version be available? I suspect we will communicate to those who signed up via that route. But yeah, look out and we'll let you know when that's available.